So you will be having some different windows. So there are four windows. One is your workspace, and the other one is object, and the wave default, and the fourth one is your transcript.
Hmm.
So this workspace is the path where your design is available and what is the unit and what is the visibility and all. So it is also called as instance. Instance is nothing but the module, and the variables which are all available in this particular module will be called as object by this model sim simulator. So the objects are nothing but A, B, Y. These are all my variables. So
Hmm.
these variables to be transferred to a wave window to cross check whether I am able to get the result or not. So here comes this kind of definition. So inputs are to be defined with net. So we have seen that internet port connection rules, right?
Yes.
So in either register or net. When I go for behavioral modeling, it is a register. For other models, it is net. So A, B, and as well as X, my Y is my output. So again, it is the output side. So it will be again a net. So already told inputs are A and B. So it should be with HIZ, high impedance state. And output is my X value, STX, unknown value. So if anything is different in this, so I have defined A as a input, but if I see here as STX in place of HIZ, which means I have misconnect. The connections are misplaced. The variables are wrongly defined or declared. So it is not, the program is wrong. We have to rewrite it. Before executing, you can able to check whether the variables are declared properly or not. So here the variables are declared properly. Now I am going to simulate and see the output waveform by maximizing the wave window by using this pop in pop out symbol. So we have already seen in the program the output will be either in the nanosecond or in the picoseconds. If you see the scale, it is of in picoseconds from 200 picosecond, 400 picoseconds. So initially there is no data for A, B and Y, but if you see in the object window, it is HIZ, HIZ, HIZ. So here it shows no data at the initial stage. Now I need to force my input values A and B. Let me select A, right click. So I'll go with force. Click on this force. So no need to change anything in the signal name. You can cross check which variable you are going to assign. So it is a variable A and it is HIZ. So it is nothing but my input value. And you need to specify what is the size of this A. So what will be the size of A here?
It will be 1 bit because we haven't defined
Yes.
anything in our.
So we need not to bother about it. The number of widget at this place is the size. So
Size.
here it is only one widget.
Hmm.
So it is a 1 bit value. So as it is AND gate, first combination is 0 0. So let me give 0 for A, and no need to change anything in this kind or delay and all. Then
Hmm.
click OK. Then similarly select B and force again first
One
combination it is 0. Click OK. Now me not to force the value for my output value, output
bit.
variable. Now click on this 100 picosecond. Next to it, we have a down arrow called run.
Hmm. Hmm.
Click
Hmm.
on this run one times or two times.
So
So
it
you will get the
A and B value will start from 0, right?
yes.
Hmm.
So because 0 0 is the first set of input combination for an AND gate.
Hmm.
So I am giving my inputs is here 0 0 and my output is also 0.
0.
So by moving this yellow color cursor, I can able to check what is the output.
Hmm.
So now I need to go for the next set of input combination. A will be 0 and B will be 1. So let me change it to 1. So even deleting STX as completely 1 or this is also possible, no issue. So now it is I have forced 0 1, but you see here the data is not changed for the A and B as
Hmm.
because my cursor
Hmm.
is not moved. So I move my cursor 0
Hmm.
1, again the output should be 0. The other condition is, so if you want to select multiple variables, press Control
Hmm.
and select all the variables, then
Hmm.
force. Now it will be 1 0 and run again.
So it comes
For
to
1
one.
0 also
Hmm.
it will be 0. And
Hmm.
the last combination is
Hmm.
1 1. So
Hmm.
1 1 it is an AND gate, output is 1. So now if you want to file this one, you can take this export image and
Hmm.
or say format as anything you can take, or using snipping tool you can snip it, and in the
Snippet.
paint invert color whatever you want you can save it for your reference. So again
Okay.
pop it up to this. So this is how you can write a Verilog code for an AND gate. Similarly, if I change the symbol to OR gate, so
Orchid.
OR gate is a straight line, so which is nothing but in the keyboard above the enter key you will be having a straight line. So shift and forward slash you will get this R symbol. Now it will become OR gate.
Hmm.
So once I changed anything, even a small change in the program, I need to
Hmm.
start from the beginning. Again, I need to start from the beginning. So as I change the R gate, if I go to the wave window and change the values, I will not get the output of R gate. I will get the output of my previous program, that is
Previous.
AND gate. So instead of going like this, you can double click on this synthesis XST. So you will get everything checked,
Hmm.
and then you can go for launch models in simulator. When you go
Hmm.
for the next program, it is better to close the model sim which you have already running.
Hmm.
So for our easy understanding that this program is there. Otherwise, you will be having plenty of model sims. You don't know
Hmm.
which output is for which program.
Which one?
So close everything and open new model sim, and you can force and check the output. So
Hmm.
here it is. Let me go with the 0 1 combination.
Hmm.
So it is an OR gate. If one of the input is 1, my output should be 1. So the output
Hmm.
is 1. So if I use cap,
Hmm.
then it is nothing but my XOR gate.
Excel.
XOR gate. If I use a tilt in front of it, so tilt of cap, it is XNOR.
XNOR.
Tilt
Hmm.
of XNOR.
Hmm.
Then if I use AND, so this will become NAND.
And.
Not of AND, so it will become NAND. Similarly, if I use not of OR, then it will become NOR.
Hmm.
And if it is y is equal to not of A, then it is
Hmm. No. Nor
complement of
gate.
A or inverter or an inverter, simply an
Hmm.
inverter.
Inverter.
Either you can use this exclamatory symbol or this tilde, both are gives you inverted
Hmm.
operation. So this is as I told you, a double slash will be a single line of command. So
Hmm.
see here, this will become a green color, then it is a single line. For the multiple line command, this is a multiple line command. This is a multiple line command. So within this multiple line command, I have a single line of command. So this is also possible. So for your better understanding, when you are writing a program, if it
Hmm.
is a keyword, it should be in blue color. If it is an identifier, it should be in black color. Suppose if you are
Yeah.
writing an output, if it is yeah, there is a spelling mistake,
Hmm.
then it will become blue, black
Hmm.
color, and when you
Hmm.
are running, it will tell us
Hmm.
output variable y is not declared properly. So because of the spelling mistake, also it will throw an error. Sometimes you will get an it will show error as at line number 24, but
Hmm.
actually the error will be in line number 23. So you have to check the first line and the previous line and the next line when you
Hmm.
get an error. Need not to
Hmm.
check the particular line now. So this is an off adder.
Hmm.
Have you seen this off adder circuit?
Yeah, but actually, it's been a little time. So, can you like explain the circuit as well?
Off adder.
Like,
I'll explain. Off adder is nothing but it's an adder.
hmm.
Off means it is having a two input, two output. So input will be 2 and output will be 2. So A
Hmm.
and B will be your inputs. Sum and carry will be the output. So the sum expression is A X or B, and the carry expression will be A and B, A dot B. So A dot B means it is an AND gate. So you will be having an AND gate. A
Hmm.
XOR B or A cap of B as we will be using in the program. So it is an XOR gate. So what is the input? Inputs are A and B. So
B.
inputs of the XOR gate is A and B. Similarly, A dot B. These are the inputs of my AND gate, A and B. So if I this is a common for both this gate G1, I'll say it is an XOR gate,
Mm.
and gate 2 is AND gate. So
Okay.
A and B is common for both the gates. So I can connect like this. Common connections I can able to
Mm.
make. And the output of XOR will be my sum. Output of this AND gate will be my carry. So why
Carry.
it is a sum and carry? As it is an adder, obviously you will be having
Some.
sum and
Like.
carry. As
Mm.
because we are using with zeros and ones, binary
Mm-hmm.
values, there is a possibility of getting zero. This will be zero and this one. So this will be the sum and this will be the carry for this
Sorry.
data.
Mm.
So here I need to write, I know the Boolean expression now. I know the Boolean expression for my sum
Mm.
as well as carry. I need to write a code. So
Mm.
when you go for this, this is your main module. This will be your main module.
Mm.
The two gates to be inside this. So
Mm.
main module will have two inputs and two outputs. That is the main.
Mm.
So when you are defining module half adder, it is a data flow modeling. There should be only four variables at this port list: sum,
Mm.
carry, A and B. Already told, first output variable, then the input variables.
Mm.
So sum and carry are my output, A, B are my inputs. So again input and output. At this order you can interchange, no issue.
Mm.
So there won't be any problem with this. Then again it is a data flow modeling. The keyword is assign. So assign sum is equal to A XOR B, and
Mm.
assign carry is equal to A and B. And here also you can swap. First you can define carry, and the second you can define your sum. No issue. Then end model.
Mm.
So you will get an output of this half adder. So again it is a 2-bit value. You will have 0 0 0 1 1 0 1 1. So
Mm.
what will be the sum for this condition when it is 0 0?
It will be for some for XOR it will be
Yeah.
uh
Then you will get output 1 when you go for XOR gate.
so when all the outputs are low, I
0
think.
1 1 0 1 1. When one of the output input is high, you will
Hi.
be having 1. For the
Okay.
remaining conditions, it will be 0. This is for XOR gate. So
Hmm.
when it is 0 0, XOR output will be 0. When it is 0
Hmm.
1, one of the input is high, so output will be high. Here it will be
Okay.
high, and here it will be 0.
Zero.
Similarly,
One of the
carry,
outputs should be high.
yes, to get the
Okay.
XOR gate
Hmm.
output as 1. So for carry, it is a multiplication, normal AND operation, 0 into 0 0, or 0
Zero.
into 1 0, 1 into 0 0. So the same way you can write a program and you can simulate it in the simulator, and you can cross check the output, right?
Uh, yeah.
Okay. Shall I want to simulate it, or
Uh, yeah, we can check
yeah?
simulating it.
So now, when you go for the next program, you need not to create again a new project. You keep all
Hmm.
your modules in a single project. And
Hmm.
sometimes when you go for a multiplexer or decoder, encoder, you have to
Hmm.
call your AND gate programs as a submodules. So in that case, you don't know in which name you defined this module, right? So you have to call only this module name. You don't know what is the name of it. So to get to the name, better to keep all our programs in a single file. So for
Hmm.
the my next program, I'll select as again a new source, Verilog module. So it is a half adder using data flow modeling. So again, it is a Verilog module, half adder using data flow modeling, and click next, next, finish. So I'll get this. The hierarchy is been added here below the same device.
Hmm.
So half adder, I will have my sum, comma, carry, comma, A, comma, B. There were four variables. So inputs are nothing but A, comma, B. Similarly, output is sum, comma, carry, or C, comma, S. That is also possible. No issues. In two assign statement, assign S is equal to A cap of B,
Hmm.
and assign carry is equal to A and B. So that's all. Save. So now
Hmm.
see here, this gray color is highlighting this half adder, which means, as I already told, the recent program. If you click save, the recent program will be executed. can
Hmm.
see here compile he underscore d. But if
Hmm.
you want to, you might be thinking that you have a AND gate program here,
Hmm.
and you are thinking AND gate has to be
Hmm.
simulated or checked syntax, but it is selected half adder. Then if you say only half adder will execute, not the AND gate.
The
So
and
you have, yeah, you have to select the particular program which you need to. So no error. Let me close this. So again, A, B are my inputs, C and S are my outputs. So they are STX and they are my inputs HIZ. So first I'll force 0 0. My phone
Hmm.
away. Phone away. Phone papa. So both are 0 0.
Hmm.
So as both are 0 0. Next is 0 1.
It will be one.
For 0 1, the sum will be 0, carry will be, sum will be 1, right?
Hmm.
Yeah, sum is 1 and carry is
And
0
that is zero.
because one of the input is high. So the
Hmm.
other combination also will be same. And for 1 1, it is sum will be 0 and both are 1 1. So sum will be 0 and carry will be 1. So
Hmm.
same inputs will produce output 0 for XOR gate, and for
Hmm.
carry AND gate value. So 1 into 1 it will be 1. So this is for half adder.